Hello and welcome. I'm Michael Ochs, and in this video I'm going to talk about how to build better document-centric apps. Document-centric apps are a big part of productivity tools, especially on the iPad. There are three types of document-centric apps. Those that allow browsing documents, such as the Files app. Those that allow viewing content, for example, Quick Look. And those that also allow editing or creating content, like Pages, Keynote, or Numbers. This video focuses on improvements to viewer and editor apps, but some of the content discussed also applies to browser apps. iPadOS 17 introduces a new view controller that automatically enables a large number of features in your app. It works nicely together with the desktop class iPad APIs introduced in iPadOS 16 and the existing document-centric APIs. This new view controller is built in a modular way. You get great system defaults, but can customize any individual behavior. To catch up on desktop class iPad APIs, check out Meet Desktop Class iPad and Build a Desktop Class iPad app from wwdc2023. For SwiftUI development, Document Group now has support for all these features with no additional code. To learn more about the SwiftUI side of this, check out Build Document-Based Apps in SwiftUI from wwdc20 and SwiftUI on iPad Add Toolbars, Titles, and More from wwdc2022. In UIKit, the functionality is opt-in. UI Document View Controller is a new base class for content view controllers. It works together with UI Document to automatically configure the navigation bar. This enables features like sharing, dragging the document, undo and redo support, and more. It also supports automatic renaming. In this video, you'll learn how to use UI Document and how to present documents with UI Document View Controller. I'll then explain which features are built in and how to customize them further. At the end, I explore some best practices to migrate your existing apps to take advantage of UI Document. First up, creating a document. The core of every document-based app is UI Document. It's an abstract base class that is meant to be subclassed for each file type that your app supports. All UI documents are backed by a URL. Files on disk are the most common, but you can also save and load your documents using a database and a custom URL scheme. UI Document's load and save operations are asynchronous, which allows for lengthy read and write operations if necessary. For this reason, UI Document is thread safe and takes care of coordinating access through locks and queues. When implementing a UI Document subclass, there are two main responsibilities to take care of: loading and saving of the document, and providing access to the content of the document. Loading and saving is very similar across all documents. Accessing the content is more specific to the type of document and how it is used in your app. For example, a document model for a Markdown editor might only have a single text property, or it could expose a more complex interface that allows updating individual parts of the document. Before we talk more about accessing the content, let's talk about loading and saving. For simple file-based documents, there are two convenience methods you can override. When a document gets opened, load from contents of type will be called with the contents of the file. When the document is being saved, contents for type is called to get the current content of the document. The content of the document is a data object for regular files or a file wrapper for everything else. To learn more about file types and how they work, check out the Tech Talk Uniform Type Identifiers, a reintroduction. For example, here, the document deals with regular Markdown files, so we expect a data object. Now, if you want total control, overriding Save to URL for save operation and Read from URL instead gives you full access to the URL and leaves all reading and writing to you. This is great if you want to store your documents in a database or have special requirements for reading and writing your document. Note that while the save operation is asynchronous, reading is expected to complete by the time the method returns. And this is all there is to loading and saving a document. Now, let's make sure we have a way to access the content of the document. An easy way to provide access to the document's content is by adding properties for that content. In this example, I add a single text property that contains the full markdown string. This property will be set when loading the document initially, as discussed on the previous slides. The app can then update this text whenever the user edits the document. For UI document to know when it requires saving, call update change count every time a property updates. Calling update change count allows UI document to mark the document as needs saving and automatically save at appropriate times. Next, presenting a document with the new UI document view controller. Similar to UI document view controller also is an abstract base class that is meant to be subclassed. It manages opening, saving, and closing the document and populates its navigation item with information from its associated document. This includes the title, the navigation item's title menu, its UI document properties object, and the rename delegate. UI document view controller also provides key commands for common actions like undo and redo. Let's check out how to implement a UI document view controller subclass. There are two methods that are designed to be overwritten by your subclass. When the document associated with the view controller gets opened, or when an already opened document gets assigned to the view controller, document.didOpen is called. Populate the view controller's views to display the content of the document in this method. Note that there's no timing guarantee between when document.didOpen is called and when the view controller's view gets loaded. A good approach to write robust code is to move the view configuration in its own method and call it from both document.didOpen as well as view.didLoad. Check if the view is loaded and the document is opened before configuring your views. The second method to override is navigation item didUpdate. Whenever UI document view controller makes changes to the navigation item, it will call this method. Add your navigation item customization in there. UI document view controller will make a best effort to keep changes to a minimum to persist your changes as best as possible. UI document view controller also offers an undo redo item group. Put this group in the navigation bar if you want undo and redo buttons to appear, and make sure that your document has an undo manager assigned to it. UI document view controller will change the hidden property of this group depending on the availability of an undo manager, and enable or disable the buttons inside the group as necessary. UI document view controller automatically opens and closes the document. However, if you need access to the document from outside the view controller, call open document with completion handler. UI document view controller will make all the necessary callbacks, such as calling document.didOpen and call your completion handler when ready. Last but not least, UI document view controller provides a document property. This property always refers to the document associated with the view controller. While you can provide a document during initialization, it is entirely optional. When there is no document associated with the view controller, it will automatically show an empty state. To learn more about configuring empty states, check out What's New in UIKit. Furthermore, UI document view controller can be used as your app's root view controller. If there's no browser view controller in a hierarchy, UI document view controller puts a document button in the navigation bar that opens a document picker. This requires declaring the key UI document class for relevant file types in your app's info plist and setting it to the UI document subclass matching that file type. In iPadOS 17, UI document conforms to UI navigation item rename delegate and will handle the underlying file changes by itself when the user invokes renaming from the title menu. If you're using UI document view controller, it will automatically configure renaming for you. Otherwise, you can set the document as the navigation item's rename delegate manually. These are all the pieces you need to create a great document-centric app in iPadOS 17. Next, how to migrate your existing apps. Migrating your app to make use of the new UI document view controller is easy and only requires 3 steps. First, update the base class of your content view controller. Second, move existing code to the new callbacks. And third, delete code that is no longer necessary. Let's check out how to convert the Markdown editor example we use in the desktop class iPad app videos. If you're not familiar with it, don't worry. I'll walk you through the relevant parts of the existing code first. So here we have the definition of the view controller at the top, the document property it defines, and an init method that sets the initial document and then adds a callback to our document. First, we change the base class to UI document view controller. Now that this class inherits from UI document view controller, we will get a compiler error because the property document already exists in the superclass with a different type. We change the name of that property to a more specific one, like Markdown document. Then we make it a computed property that casts a generic document property to the specific document class used in this view controller. The last bit in this code to take care of is the initializer. The only code in there that we still need is assigning a callback to our document. Since the document can change during the lifetime of this view controller, we move this to execute every time the document changes. An easy way to do this is to override the document property and add a did_set callback. Great, now that the base class is up to date, we need to take care of the new callbacks. In view_did_load, we add buttons to our navigation bar and configure it to allow toolbar customization. For UI document view controller, we move this to the new callback navigation item did_update. Next, our class already has a method did_open_document. This is almost what UI document view controller has as well, we just need to rename the method and adjust for the fact that the document is now optional. Alright, next the part that we all enjoy most, deleting code. Editor view controller conforms to UI navigation item rename delegate, but we no longer need that. UI document does all renaming for us automatically. So we remove the delegate definition, the delegate method with all its code, and also the rename delegate assignment. Next, we can remove a few more navigation item customizations. Both style and back action are configured by the document view controller automatically, so we can get rid of this completely. There's also a update document properties method that is used to create a UI document properties object. This method is called from various places. However, we don't need it anymore. UI document view controller is doing all of this for us, so we can remove it and all its call sites. And that's all there is to do. The editor view controller is now only taking care of the features that are unique to the app. It no longer has to manage basic tasks of document management or default configuration of the navigation bar. Instead, you can focus on the pieces that are unique key elements of your app. This is all you need to know to take your document-centric apps to the next level and provide your users with a great experience. Convert your data models to use UI document. Then convert your content view controllers to use the new UI document view controller base class. After that, go through your view controller and remove all the code that's no longer needed. Thanks for watching.